All right, so what we're going to do today is we're going to talk about normal distributions. So first we want to talk about different types of data that we can collect. So we can collect what we call discrete data. Now, discrete data is data that can only take on certain values. So for example, if we're talking about people, you can have one person, two person, three persons, but you can't have 2.8 people, okay? You can't have 72.5. You can't have those like points of a person. Continuous data. So discrete probability distribution, it has a finite number of possible events or values. Now, continuous data can be any value in an interval of real numbers. So for example, if we're talking about weight, you can have those point whatevers in weight. Same thing with length or blood pressure. Okay, those point or those decimal values are all valid for those measurements. So many common measurements, such as human weight, height, blood pressure, gathered in a natural world, tend to have what we call a normal distribution. So a normal distribution has data that vary from the mean. That vary randomly from the mean. And their graph is what we call a normal or a bell curve. And this is kind of what it looks like. So it starts off low, it increases, and then it decreases again. And this middle value, or this middle height, is our mean. So what normal distributions happen is notice that it's very tall next to the mean. This means that there's more data next to the mean. So more data is close to the mean than is further away. So for example, if we're talking about human height, so if the average height of a female is 5'5", okay? That means there's more people that are 5'3" or 5'6" versus 6'5" or 4'5". More people are closer to the mean, less people are further away from the mean. And the amount of people, or the percent of people that are close to the mean, actually follows a normal distribution. So we've got this picture, and this is called the empirical rule. So what the empirical rule says is that, remember how we kind of did our standard deviations a couple lessons ago? The empirical rule says that, well, within one standard deviation, 68% of our data. So 68% fall within one standard deviation. So 68% fall within 1, so that's 34 to the left and 34 to the right. Now if I go out 2 standard deviations, this would be 95% of the data. So 95% of the data fall within 2 standard deviations. And then if I go out 1 more standard deviation, 99.7% of the data falls within 3 standard deviations. So normal data is always centered around the mean. 68 fall within 1% of the data. 95 fall within 2. So if I add up 13.5, 34, 34, and 13.5, that's 95% of the data. And then 99.7% of the data falls within 3 standard deviations. You will need to memorize this. In fact, it might be helpful to memorize this whole bell curve. You can get, if you remember these parts, you can get these. So 68, you divide it by 2. To get 95, you subtract the 68 and then divide it by 2. To get 99.7, you subtract the 95 and then divide it by 2. So sometimes data are not normally distributed. Data sets that have a distribution that are skewed or asymmetric. So if it's skewed, it does not follow the same predicted mean. It does not work the same percentages. So when we have data that's skewed, if your tail goes to the right, this data we can say is positively skewed. Or sometimes they'll simply say right skewed. If your tail is to the left, this would be negatively skewed or left skewed. So again, if it is skewed, the data does not follow those predictable values from the mean. So it does not act like normal distribution, and it's inappropriate to use means and standard deviations to estimate the percentages. Problem 1. The bar graph gives the weights of a population of female brown bears. The red curve shows the weights are normally distributed around a mean of 115 kilograms. The question is approximately what percent of the female brown bears are between 100 and 129 kilograms. All right. So we're looking what percent is between 100 and 129 kilograms. So we're looking at this data. So if I look at this height of this bar looks like it's about 23% of bears are within that height. If I look at the height of the next bar, this one looks to be about 42%. And my third one would be 23%. So I would do 23 plus 42 plus 23 again. So this equals 88. So approximately 88% of the bears are between 100 and 129 kilograms. So what I'd like you to do is pause the video, try the U-try. All right, go ahead and check your answers. So approximately what percent of female brown bears from problem 1 weigh less than 120? So what you do is you go and look at the thing. Less than 120 would be all of these. So 42 plus 23 plus 5 plus 1 should give us approximately 71%. Now, approximately what percent of bears weigh within 1 standard deviation from its mean? So remember, the mean is 115. It said that on the first prompt of the problem. 1.5 standard deviations. Well, if 1 standard deviation is 10 kilograms, 1.5 would be 15. So within 1.5 standard deviations means we add and subtract the 1.5 standard deviations. So we're looking between 130 and 100. So the percent that is between 100 and 130, well, this is the same as the previous problem. So this would be 88%. Problem 2, for a population of male European eels, the mean body length and 1 positive and negative standard deviation is shown below. Sketching normal curve showing the eel lengths at 1, 2, and 3 standard deviations from the mean. So first, let's find out what is the standard deviation. So we know that the mean is 15.7. If I add 1 standard deviation, I'm getting 18.5. So what am I adding? Well, I'm going to subtract those two numbers. So I get that a standard deviation should be approximately 2.8. Because if I add 2.8, I get 18.5. If I subtract 2.8, I should get 12.9. So I'm going to go to a blank slide. You guys are probably just going to want to use the margins to write this. All right, so let's draw a normal curve. Now the height that you draw it at doesn't matter. Your mean goes in the middle. So this is 15.7. This is our mean. Now if I go 1 standard deviation to the right, I'm adding 1 standard deviation. So this is 18.5. And if I subtract 1 standard deviation, I should get 12.9. So what we want is between these two, there should be a standard deviation of 2.8. Now, I want to go out 3 standard deviations. So this would be plus 2 standard deviations, plus 3 standard deviations. And we do the same thing on the left side. Minus 2 standard deviations, minus 3 standard deviations. And each one, I should be adding and subtracting 2.8. So if I add 2.8 to 18.5, I should get 21.3. And if I add another 2.8 standard deviations, I should get 24.1. If I subtract 2.8, I should get 10.1. And if I subtract another 2.8, I should get 7.3. So here's kind of a sketch of my normal distribution. You don't need the plus or minus on the outside, and you don't need these 2.8s. What I'm looking for is that you have the curve and you have these values drawn down here. So what I'd like you to do is try the U-try. So go ahead and pause the video and try this U-try. All right, so go ahead and check the U-try. So basically your mean should be in the middle, and since the standard deviation was 4.7, you're adding 4.7 as we go to the right and subtracting 4.7 as we go to the left. So when we had a bar graph, the height of the bar indicated our probability. Now, if we have a normal distribution, so the height of the bar graph, we had the bears problem. For a normal distribution, the height doesn't matter, and it's the area that's between the interval that matters. So this is like the eels. So problem 3, the height of adult American males are approximately normally distributed with a mean of 69.5 inches and a standard deviation of 2.5. What percent of American males are between 67 and 74.4? So I left a blank slide so that we could draw our normal distribution curve. All right. Our mean, 69.5. Standard deviation is 2.5. So if I'm adding 2.5 as I go to the right, and I'll subtract 2.5 as I go to the left. So 69.5 plus 2.5 would give me 72, plus 2.5, 74.5, plus 2.5, 77. Subtract 2.5, so I'd get 67, 64.5, and 62. Now we remember those percent values from our normal distribution slide. I'm going to go ahead and fill these percents in on my distribution, on my normal distribution. So this is 34%, 34%, 13.5%, 13.5%, and 2.35%, 2.35%. Now, another thing to notice is that half of your data is also 50%. So if I was to go this way, so 50% is greater than the mean, and 50% is less than the mean. So what percent are between 67 and 74.5? So between 67 and 74.5, I'd add up 34, 34, and 13.5. So 34 plus 34 plus 13.5 equals 81.5%. In a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet? Which is 72 inches. So taller than 72 inches means we're finding this percent of the data. So notice I don't have any value for this tail down here. What I'm going to do is I'm going to use the fact that half of it has to be 50 and subtract this 34. So 50 minus 34 equals 16. So 16% need to be taller than 6 feet. So 16% of 2,000 would be 0.16 times 2,000, which should be about 320 males. So out of that group of 2,000, we'd expect about 320 of them to be taller than 6 feet. All right, go ahead and try the U-try. So what you'll want to do is make your normal distribution and then answer your questions. So go ahead and pause the video and see if you can do this. So remember, you want to make your normal distribution curve here first. All right. So first off, you wanted to start off by making your distribution curve and filling in your percents. So you have these values on the bottom and the percents in between them. So A, the probability scored above a 180. So that's this yellow section that I kind of highlighted. So anything that's you're including the tail probability, you want to include the 50%. So I'm taking 50% and I'm subtracting these two away to get this remainder here. So this would be 2.5%. Scored above a 135, so that would be this orange section. So half of it is 50 plus this 34. Gives me 84%. So 84% of 250, I do 0.84 times 250 to get 210. And then C, if 13.6 got a B, well, I know a B has to be bigger than average, greater than average, so I'm going to the right. So the area that contains something that's around 13.6% would be about this section here. So this section here has scores between 165 and 180. So a B would correspond to 165 to a 180. All right, so that's all I've got today. Have a good one, guys.